Hey, what's going on, guys? GoodmanGeekinZ here. In this video I'd like to introduce the new version of Wukong JS JavaScript JS engine I'm currently working on. This is version 1.3 and it's around 1720 elo points, 1720 elo points strength here. So just to give you an idea, regarding the very last tournament I ran versus TSCP, this was 100 games match with the time control 2 minutes plus 1 second increment. It scored 46%. Well, obviously some rating bounds are, I don't know, not sure, plus minus 50 for about 50 elo points. I'm not sure. It's, you know, like the more games you run, the more accurate results you're having. But just visually, when I've been exploring these games, I now understand that it's now kind of like really playing nearly the strength of TSCP. Well, even though that TSCP has 1723 in Blitz, and it's probably still WukongJS is a little bit weaker, but still, well, some people say that TSCP is for about 1800s, so it's really hard to say, but I think this rating, like 1720, is more or less like a fair rating for the current particular strength of WukongJS chess engine. So feel free to test this versus actually feel free to test this. First, I didn't really want to make this version kind of emphasize this version, but then I realized that I'm now really into automated tuning for the evaluation, and it really takes time and effort. So I just decided it would be a good idea to provide somewhat a fixed version of the previous 1.2. And just a few notes regarding what I've changed, what's new here. So let's start from the very beginning, basically. So oh, sorry, it's not this one. JavaScript code part here. Yeah, so I was experimenting with two sets of p-square tables. So if we just go to the evaluation, both are provided by Ronald Frederick. Well, actually, yeah, I just need to update this description because it's no longer true, basically. So Ronald Frederick is the great guy who helped me to understand how, in particular, automated tuning in general and Texel tuning in particular is actually working. And also provided this evaluation p-square tables, material weights, and game phase margins from his engines RofChade and PeSTO. Both are closed source, so they're not open source yet. Well, hopefully he would open their sources one day, but now they're not available. And well, both however, both sets of p-square tables are available in public, and from the permission of Ronald, I will share these values with you guys, so you would be able to use them as the only evaluation, basically, of your own engines to play around with, which is very interesting. A few words regarding the tables. So I've dropped back to RofChade tables, and initially in the version 1.2 they were RofChade engines tables. Well, I thought that was PeSTO's, but that was RofChade's actually. And then I actually asked Ronald to provide me kindly his exact PeSTO engine, which is 3000 plus elo points, as is already in here. And he did, but those tables, well, for some reason, at least for me, in this engine, they worked kind of much worse compared to the RofChade ones. Despite the fact that the PeSTO tables are not intended to be supplemented by whatever other evaluation parameters like pawn structure evaluation, king saver or something, but at the same time, while RofChade's one, this ones, they are actually about to be supplemented by additional evaluation parameters, as it is done in Ronald's RofChade chess engine. But for some reason, in my case, in Wukong, RofChade's p-square tables are working much better. and especially after I've fixed some evaluation pruning related bugs in the search, which I'll point out just right in the moment, which is incredibly important, guys, for you, because a noob like me, you know, like I was really making these horrible bugs and producing these horrible bugs without much idea of that actually kind of horribly wrong. So yeah, I've dropped back to this RofChade's tables. I will give you the links in the description below this video to both sets of p-square tables, to make sure that you can they are free now, so they are okay to be exposed into public, so just feel free to play around with them. And now let's go to the search part. So there are a few sensitive parts within the search that are related to evaluation pruning. So the first is the evaluation pruning itself. So here we need to use the evaluation margin should be relative to the weight of the pawn, of the single pawn in the opening. While it was some standard value like 100 or something, which wasn't reflecting the actual value of the pawn. While here the actual value of the pawn is 82, if I'm not mistaken. So let's have a look at the evaluation one more time. So the value of pawn in the opening is 82. Okay, so okay. So this is the first disaster to fix here. So now and a few fixes regarding the evaluation margins resulted about, I don't know, around 1500 L points strength growth compared to the previous version, because again, like bearing in mind the fact that I've dropped back to the original RofChade tables that were used in version 1.2. The only thing that is actually different in this version is are these fixes regarding the evaluation margins all along the way. So another place is within the razoring. So again, like I'm using the related to a relative value of white of a pawn in the opening, and then the value of that pawn multiplied by like pawn and a half, basically. Oh man, I've just realized. Hold on a sec. Yeah, I've just found. Okay, I've just found another horrible bug in my sources. Yeah, so probably now it would be even a little bit stronger, because yeah, because razoring should now be much better actually. Okay, just forgot to fix this one. Well, okay, so it would be interesting to test, run another 100 of games to see whether it's better or not. This should be better. This definitely should be better. So yeah, actually, so this is the second part within the razoring. Just want to make sure that store everything. Okay, what else? Yeah, futility pruning. So the condition to consider the futility pruning is here, and again, like we're referencing the futility margins that are relative to the material weight. So pawn, knight, and the rook. So that's how it's done now at the moment. Okay, so I guess this is it. Yeah, it's really nice to make videos because you're revising your code, and I will probably never ever see this horrible bug in razoring that I was sure I fixed all the bugs there. But yeah, material weights. Okay. Just hold on a sec, guys. I just want to make sure that material weights are fixed all along the way. So make sure either opening or endgame goes after material weights. Okay, yeah, it seems like now this is kind of much better. Yeah, so now it should be searching slightly better. Okay, so this is it regarding the updates of the new version, and now I just want to announce a new very intriguing kind of stuff that I'm kind of working on now. So Texel's tuning. I would definitely make absolutely separate video dedicated like to Texel's tuning, entitling that video something like, I don't know, a very gentle intro to Texel's tuning. Maybe that's That would be the nice name. So here I have a draft implementation of my Texel's tuning, and just a few words about this. So I've implemented, well, there were kind of two ways of how to proceed. I could have implement it in JavaScript and connect to my engine, but in that case, I need to create really lots of additional stuff like generating FEN string from the position to extract it and so on. Well, maybe if I would be using the already existing data set, probably in that case that wasn't really necessarily needed. But anyway, Python is faster than JavaScript, so it's one of the reasons to consider it. Another reason to consider it, it's incredibly easy to actually duplicate the evaluation function, exactly the same instance of evaluation function that I had in my chess engine. And here are all the parameters to tune basically. So we're gonna be tuning the p-squared tables, material weights, and endgame and opening material margin scores, material phase margin scores. It might look like a little bit tricky. Why am I using this? Like dumping everything together? Well, that's the reason for doing that is because in the exact implementation of Texel's tuning that I'm following, the easiest possible out there basically is we need to loop over all the parameters to tune in order to adjust them either by +1 or by -1. So just to make it easier to loop over all the tunable parameters, I've dumped them like this. And also there is a specific logic to convert to actually kind of map materials, p-squared tables, and all this stuff to specific variables to make it easier referencing within the evaluation. So I'm using this. I'm creating the variables to map the specific indices to those parts of the weights that I actually need. And again, like I've also implemented the question search and even the MVVLV move ordering, because otherwise it's just slow as hell. But with this, it works quite pretty nicely. But again, like the data set to work with is the set of FEN strings, so it's like very big list of FEN strings. And just to speed up the process, we can use evaluate directly instead of using questions. But in that case, we need to make sure that we don't have forcing lines within our position. So that's another kind of reason to prepare your data set appropriately. At the moment, I'm testing the already existing data set, testing with the already existing data set that already has those quite FEN positions being extracted. But also, I'll write a function to process the PGN file to pick up only quite position from that, and to write the file with the FEN strings and with the additional and with the results of how the corresponding results. So every position has a result of the game this position relates to, either win, draw, or loss. And that's needed in order to calculate the mean square error at the very end. So yeah, that's kind of it. And something that I'm already proud of is I've created a function that gives this sort of a textual file as an output, so I can simply grab the entire adjusted scores and just copy paste them to the tuned version of my chess engine, Wukong JS. So so this is the output of the Python script. So that's another good thing. So I'm making this exactly to be like in the format of what I should have at the very end. Well, actually here I'm just I didn't yet make any tuning yet. So these are just the eventual values to tune. And again, like I was asking guys on TalkChess, and they say that one can even start with the absolutely blank values like all the zeros or even the random numbers. The random numbers, believe it or not. So that's just a matter of how long the testing tuning would be running, how many sessions. It's really time consuming, it's especially bearing in mind the most primitive implementation I'm currently going for, because a little bit. Okay, guys, I'm sorry. Sorry guys, this is my wife's phone is calling. Okay, so just completely lost my thoughts. Sorry for that. So man, what I was talking about? Yeah, what I was kind of talking about. Well, okay, so probably just time to finish this video because nothing really much to be said here. Yeah, so it's we can use the completely blank values. It's the matter of how many times, so how many sessions of Texel tuning is about to be done there. So if I were to succeed with this, I would be really happy to make a video on covering this, the most basic Texel tuning implementation. So I'm taking the values, I'm taking the weights from the JSON file, then I would be running the tuning routine, and then eventually I would be outputting this textual file with all the weights being adjusted. So the only thing would remain then is just to grab this, copy paste to the tuned version of my engine and try to run a test to see whether the minimizing of the mean square error actually results the growth of L points, the L strength of your chess engine, or not. So that's how the thing's done basically. And first, I will try this with the existing quite FEN file. There are really lots of those, and when it comes to sharing the Texel tuning results, I would definitely share the links to the data sets I've been using. But again, like I really want to generate eventually, I want to generate my own data set from so-called gem to 2600s.pgn file. So these are the games like from the world championships, like Fischer's Pasky and things like that. So quite pretty rare games, but still really strong grandmasters. So I really want to use that data set eventually to extract the positions to tune my engine from that data in particular. Okay guys, so I think this is it from my side. You just enjoy the latest version, try to test it. If you running lots of games, let me know in the commentaries, write me emails, so whatever. I'm really interested to know how well Wukong works for you basically. And some guys already reported that they are already playing around with the source code, which is really flattering, and that's I'm really happy because of that. So yeah, now really need to get back to work on Texel tuning. So hope to see you as soon as I come up with the initial results. But it takes time because again, like just my very primitive implementation really takes time. But anyway, I would be happy to share the results. Okay guys, so that's it from my side. Wish you all the best guys. Until the next time, and take care.